Bismillahirrahmanirrahim. Started with the name of Almighty Allah, the most beneficent, the most merciful. Today, the dilemma of the talk is stereochemistry. This is very specific aspect for the pharmacist, which is specifically taught particularly to the pharmacist, because there are many compounds, they exist in many stereoisomeric form, and one of them could be a beautiful drug and other stereoisomer could be beautiful poison. For that matter, whosoever is a person authority in a drug, he must be able to know what is stereochemistry. So first of all, I would like you to know what do you mean by stereochemistry. So stereochemistry is the branch of chemistry that deals with the arrangement of atoms in a compound which correlates the properties of compound. So in this respect, one thing is more important, and that is the arrangement of the atoms in three-dimensional space. X-axis, Y-axis and Z-axis. These are the three axes in which it is being displaced. That means the atoms are arranged in three-dimensional space in a different way. In one stereoisomers, atoms are in one shape, and in second stereoisomers, atoms are in different shape, and so on and so forth. This keep on changing. Under this aspect, we will be discussing what is stereoisomer or stereoisomerism and what is optical isomerism. Then molecules with more than one chiral center. Chiral means, what do you mean by chiral? Acentric carbon. Now, then we will be discussing geometrical isomers. Then we will be sharing in this aspect resolution of racemic mixture. Resolution means to resolve, to find out and make the different isomers, that is one isomer from another, we have to separate them. This is called as resolution of racemic mixture. Then conformational analysis. So these we will be discussing one by one. This is very, very important topic, and my dear son and daughters, you should have to be very clear about it, and if you can't understand anything about it, you should directly talk to me. This is very, very important aspect of a pharmacist. Without this, pharmacist cannot be completed. For that matter, this is so crucial topic that it is very, very important for pharmacists, not for the clinician, but you should have to frame to the clinician in a way that how does a drug is being used. I can give you the pretty good example in that respect. That is the atropine. A clinician drops atropine in the eye and dilate the eye and check the situation of the eye. Now, once clinician open it and place it somewhere, and second time when it apply it, results are not good. The reason behind is the clinician doesn't know what's going on with the drug. That is, when you place this drug after using and remain it open and place it in the sun, one isomer changes into another isomer, and the active isomer in the presence of light has been changed into the isomer which is not required. For that matter, this thing is very important. And what is isomerism? Compound having the same molecular weight but different in spatial arrangement. So we are going to start with this. First of all, Now the stereoisomerism, we have seen that structure of a molecule indicates the manner in which the atoms of the molecule are bonded to each other, and that the properties of the molecule depends upon the structure of the molecule. This I have already given you the definition. Now, however, any two compounds may have the same structure and still be different. Such compounds are classified as stereoisomers. Stereoisomers are isomeric compounds that have identical structure but differ in arrangement of atoms in the three-dimensional space. Now I can give you the example. Say this is one structure and this is another structure. These are two structures. Now these could be equal to each other. They can superimpose upon it like this. But if this could be like this is one compound and this is another compound. This is one isomer and this is another isomer. This has got its own specific properties and this has got its own specific properties. Now, the stereoisomers that can interconverted only by breaking and making of bonds are called configurational isomerism. Configurational isomerism. Now, if you look at, if this is one carbon, this is another carbon, there is a single bond around it, and if this isomer could be changed in this way by breaking the bond, then it is called as configurational stereoisomers. And those that can be interconverted by rotation around a single bond are called rotomers or conformers. And in this case you can see if this is one carbon, another carbon to this various ligands are attached, and this is a bond and it is rotating like this. And this is one isomer, this is another 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 isomer, and keep on changing and isomers are formed. This is due to rotation around a single bond. These kinds of isomers are referred to as rotomers or conformers. Two types of configurational isomerism are recognized, that is geometric isomerism and optical isomers. Now you can understand configurational. What do you mean by configurational? I did talk to you that is being formed by breaking and making of the bond around the carbon. They are further subdivided into geometric isomers and optical isomers. We are mostly restrict our studies towards optical isomers. So now, up to here, I would like to repeat it for you. What is stereochemistry? The branch of the chemistry that deals with the arrangement of the atom in the three-dimensional space, and upon it their properties are dependent. There are two kinds of configurational stereoisomerisms, that is called as geometric isomerism and optical isomerism. And another isomerism is also called as rotomers or conformers. So we are going to express ourselves first of all the configurational isomerism. And the configurational isomerism says this is formation of various shapes by breaking or making the bonds. This is called as configurational isomerism, and configurational isomerism is further categorized into geometric isomerisms and number two, optical isomerisms. and we will be first of all start with that of geometric isomers. Now, as this indicates geometric isomerism, consider the isomers in N-butane. Obviously, the position of the double bond may be varied so as to give rise to the 1-butane and 2-butane. However, there are 3 isomeric N-butane having the following physical chemical properties. Now, you can see 1-butane. Here is that one. So, now, this is hydrogen and hydrogen. This is bulky group attached towards this hydrogen. Now you can see this is called a structural formula of the butane. Now then we are moving towards the second one, butane. Here is bulky groups are to this side, smaller groups are towards this side. Therefore, bulky groups are toward the same side and smaller groups are toward the same side. Therefore, they are called as cis isomers. And on the other hand, if you could see one smaller group and one bulky group, and one smaller group and one bulky group, and this is categorized as transbutane. So now you can see there are 3 shapes in it, shape 1, 2, 3. So these are the different kinds of geometric isomerism. Now you can see what is geometric isomerism. Bond breaking and making has been taking place, and now you can see how many bonds have been broken here, and you could be able to have different kind of structures. And these different kind of structure has got different property as they have been arranged in 3-dimensional space. As I did talk to you, that is y-axis, z-axis and x-axis. Or other way around, you can say x-axis, y-axis and z-axis, they have been arranged. Now sufficient energy must be supplied to the molecule to break the pi bond. I did talk to you in geometric isomerism, the bond has been broken. So in this case, pi bond is broken. It's found that usually a trans isomer is more stable compound, as thus this configuration, the 2 bulky groups are sufficiently apart from each other. Now this is trans 1. Why this is more stable and why this is less stable? What could be the reason behind it? If you could be able to look into the structure says, look at these CH3, you come like this. They keep on moving like this. They keep on moving like this. Structure is not stable. Here, hydrogen, like things repel each other. Similarly, if you could see here, these are not like, they are unlike. They cannot do like this. Again, this cannot do like this. This cannot do like this. For that matter, this is transform is more stable than this one. So these are the things which I can explain to you on YouTube and presenting myself in front of you. Otherwise, Zoom is the best one. But this way has got the specific property wherein I can be in front of you and I can explain it to you. And you can talk to me later on if you have any reservation in my lecture. So I can understand. You could be able to understand what I'm saying, what is cis isomers, what is trans isomer, and what is isomer, and why trans isomer is specifically more stable than cis one. If you have got any reservation, I am available anywhere, everywhere, whenever and wherever you would like to talk to me. You can talk to me on mobile and I can let you to explain there. चलिए आप
सही है.
Geometric isomerism can occur in compounds other than alkene as well. And I have given you the previous example of alkene. Now, in particular, bi-substituted cyclic compounds exhibit cis-isomeric and trans-isomer form. These atoms in a cyclic compound may be regarded as lying in a plane. Geometric isomerism is possible when any two carbons of a cyclic compound have substituent on them. If the substituents are on the same side, this is called a cis, or on the opposite side, that is called as a trans of the plane of the ring. Free rotation and interconversion of the two isomers is prevented because two of the valence bonds of the ring carbon are rigidly held by the ring. Example of the cis and trans are as follows. Now herein you can see this is 1,2-cyclopropane dicarboxylic acid. Now you can see this is carboxylic group is on the same side. Similarly, the hydrogen groups are on the same side. On the other hand, this would be designated as cis isomers. In this case, you can see this is the carboxyl group on this side and another carboxyl group is on the opposite side. In here, hydrogen is on this side and the another hydrogen is on the other side. This is called as the trans form. Now this is cyclic compound. Cyclopropane, cyclohexane, and again this is also a cyclic compound. So not only in the straight chain but in the cyclic form isomerism also exists. Once again, I would like to repeat it for you whatsoever at the moment I have talked with you. I am containing in a way that if longer time I'll be sharing with you, it will be very difficult for me to send you the entire lecture. But that matter I'm trying to make it in a bit so that if you could be able to understand, I have to share with you and you should have to definitely share with me through your CR, GR or directly you can talk to me and share with me in this respect. But in the sharing, Zoom is the best one. Anyhow, every method has got its own limitation, but I would like to prefer here the way to teach this stereochemistry is representation by various kinds of figures. Without that, you cannot understand. For that matter, this lecture in the YouTube is very, very important. Now again, I would like to repeat it for you. I have done what is stereochemistry. The stereochemistry is the branch of chemistry that deals with the arrangement of atoms in the molecule in three-dimensional space, that is in x-axis, y-axis and z-axis, as I have just given you the example. Now, what kinds of stereoisomerisms are there? That is configurational and conformers. Now, configurational, which is made by the breaking and breaking of the bond, and whereas conformers by rotation around the carbon-carbon atoms. Now, we can say that the conformers is further subdivided into two various kinds, that is called as geometric isomerism and as well as conformers and rotamers, optical isomerism. We are sharing with currently the geometric isomerism and geometric isomerism as it is the branch of configurational isomerism, and I did talk to you. The conformational isomerism is being formed by bond making or bond breaking. So in this aspect, this geometric isomerism can be exist in straight chain compound, alicyclic compound, and also in the cyclic compound. A pretty good example I have shared with you in that aspect. This is butane, and in the cyclic form, the acyl group and the cyclopropane with the acyl group attachment has been discussed with it. So this topic is very crucial. For that matter, I used to share with you those topics which are very important and very difficult to understand. And my dear son and daughters, if you could not be able to understand any bit of it, please kindly share with me, because without knowing the stereoisomerism, you cannot be a very good pharmacist. And this is the domain of a pharmacist, to know what is stereochemistry, what is stereoisomers, and one drug can exist in how many kinds of isomers. One could be a drug and other could be a poison. For that matter, we should be able to know, to frame ourselves a beautiful pharmacist in the global village, wherever you will go, and you will be recognized by the name of institute. First of all, you will be recognized by the name of your Almighty Allah, then by your country, and then by your organization, and later on by your principals and other members who are sharing the knowledge with you. Thank you very much. Once again, I would like to request you, if you have got any reservation in this lecture, please don't hesitate to talk to me whenever you like. Always I have got my mobile with me, and always I am for your services available for you, because I am drawing a good amount for it. For that matter, I should share with you each and every aspect of it. Whatsoever is in my brain, I would like to drag down all these things as such in your brain. If it could not be done, then it is not good enough. And be fair with yourself. And if you cannot understand anything, my dear son and daughter, once again I am saying to you, please do talk to me. Thank you.